Okay, let's go back to this problem. This was stupid this morning. I was having a moment, a senior moment. Look, because I don't like the way they drew these. Okay, so this is a height, and this is not the this is they're just showing you. I've got to do a little work here. So the initial height. Let's just say the initial height is 25 meters. Okay, and so this height from up here is 20 meters. So basically, it goes up 5 meters, right? There you go. So 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 let's just do it this way. Let's just see how fast the car would be going if it was coming down here. So you get kind of a conservation of roller coaster with no friction. All right. So let's see how fast it's going down here, and then how fast it'll be going when it gets to here. All right. And we'll do it two different ways. Okay. Because I could just go from here to here and just say, oh, well, let's just take it, since it's not losing any energy to heat, chattering, friction, or anything like that. It's going to be, I can just take the initial height as 20 meters and the final height, make this 0. But let's go ahead and make this 0. Let's find out how fast it's going down here. All right. And then when we take it from here, we'll do a second part. Say, okay, now it's going to go up 5 meters. And we'll find its final velocity when it goes up 5 meters. When it goes back up to 5. So we'll do it twice. Then we'll do it one more time with setting the initial initial. I'm going to do this with initial energy equals final energy, by the way. Okay. All right. So here we go. So here's the picture, and it's on page. What page is this on your book? Page 250 of your book, if you want to open it up the file and take a look. But you see what it is, okay? And I can probably draw it here pretty quick. All right, so basically what I've got is I've got a roller coaster car here. All right. It's going to go down 25 meters. This is at 0. It's going to go back up. The total height was 25 meters from there. And this is 5 meters here. All right. And that climbs up 5 meters. There it is, just done in a different way. All right. Initial velocity is equal to 0. All right. So here's the energy. So this is what is its speed? What's its final velocity when it gets down here? All right. So once again, the only thing working on it is gravity. All right. Once again, the only thing really working on it is gravity. So here we go. So we've got 1/2. So the energy before is equal to the energy after for when we're taking it for when it gets down to here. Okay. All right, and then we're going to find the final velocity when it's here, which is what we found today. So let's find it when it gets down to there. All right, so the energy, so part 1, first fall, first hill. All right, so the energy before is 1/2 mv naught squared plus mg h naught. This is the way you do it. Is equal to 1/2 mv final squared plus mg h final. Well, h final is equal to 0. Okay, h final, and again, we're making the g's are positive now because I could have, because we've mathematically factored out the negative part by rearranging it this way. All right. So the initial velocity here is 0. The final gravitational potential energy when h final is equal to 0 is that. Okay. So we've got cancel the m's. Cancel the masses. And look what we've got. we've got V final is equal to the square root of 2GH again. All right? That's its V final at the bottom of the 25-meter hill. Now, part 2. Up the next hill. Up next hill. All right, so now it's here. Now it's going to go up here. Again, there's no friction working against it, so we're going to do the same thing. Equation before. Oh, you probably want to know what the answer is. We can do that real quick. Square root of 2 times 9.8 times 25 is 22.13 meters per second. Right there. All right. Now then, for part 2, we've got 1/2 m v naught squared. Now for part 2, this v final becomes my v naught plus mgh naught, which is equal to 0 because I'm starting at the bottom of the hill. All right, is equal to 1/2 m v final squared up here plus mgh final, which is up at 5 meters. Well, alrighty then. Let's get, we're trying to solve for this guy. We know what this guy is because we know this is 5, 9.8, and the masses are going to cancel. So let's go ahead and bring him over. So we've got 1/2 mv naught squared. So he's giving up this kinetic energy to this potential minus mgh final, which is 5, which is equal to 1/2 mv final squared. And cancel the m's. Multiply by 2. We get v naught squared minus 2g times 5. Take the square root of that, and that equals v final, which would be v naught squared, which is what I got from this is the v final that we got from here. Okay, and I've still got that on my calculator, so I'm just going to square it. So notice what I'm doing is I'm squaring the answer. Minus 2 times 9.8 times 5 take the square root of that, and I get 19.78 meters per second, which is what I got this morning. Now let's do it into one. I was going to break it up into one more video, but we don't need that. I just need a new sheet of paper to show you. Sorry, to show you this real quickly. All right. So now let's take the same picture. Taking the same picture, which had me all upside down today because of the way they were doing it. So now he starts up here. What's the final height? Final height is 5 meters. Okay. Final height is 5. Initial height, 25 meters. So let's just go from the initial height is 25 to the final height of 5. Okay. And I knew I was wrong when I said 5 at the beginning. All right. So let's just take a look at that. Again, energy before is equal to the energy after, and let's see what happens. Okay. So I've got, so you know the picture. So I've got the energy before is equal to the energy after. So I've got 1/2 mv naught squared, which is 0 in this case, plus mgh times 25 is equal to 1/2 mv final squared plus mg5. Now look what happens. look what happens. This guy goes to 0. Subtract this guy from both sides. I've got mg times 25 minus mg times 5 equals 1/2 mv squared, which is where we ended up today. Factor this out. Look, we got 25 minus 5, so it's mg times 20, just like we did today, is equal to 1/2 mv final squared. Cancel the m's again, multiply by 2, square root of 2g times 20 equals v final, and that comes out to be 19.8 meters per second. Okay? We're good? All right, I got one more thing to show you after this.